This video will cover two examples under the moles of element two-step problems. 1 through 5 are asking for how many grams, and you're given your number of atoms. So let's take a look at number 1. 1 will be a model for number 2 through 5. In number 1, we want to know how many grams of calcium, and we are given 6.02 times 10 to the 23rd atoms of calcium. And we'll set up our equality. So this is your given, this is your find, and this is your given. So let's take a look at your moles of diagram. So the reason why this is considered to be a two-step problem is because notice there is not a direct path going from your number of particles or atoms to your mass. So you have to go number of particles to your moles, that's your first step, and then moles to your mass, which is your second step. So when you start your first equality in your problem, the box you're starting in, which is your number of atoms, will go in the bottom, and the box you're going to, which is your number of moles, will go in the top of your equality. And we're going to be using Avogadro's number in this equality. Okay, so the box that we're starting in is atoms, so atoms and Avogadro's number will go in the bottom of my equality, the 6.02 times 10 to the 23rd atoms of calcium. And then moles is the box we're going to, will go on the top of my equality. Since both of these are calcium, it's going to be 1 mole because it's the same substance. Our next equality, or the second step, is where we go from our moles to our mass, and we will use our periodic table to look up the mass. So the box we're starting in will be in the bottom, which is our moles in the equality, and the box we're going to will be in the top of our equality, which is mass. So moles of calcium will go in the bottom because that's the box we're starting in. Grams is the box we're going to. And I go to the periodic table to find my mass. And I round the mass of calcium to the nearest whole number, which is 40. And since this is the same substance, it's to 1 mole. So now to solve my problem, I always multiply all of my numbers on top, write that answer down, multiply everything on the bottom, write that answer down, and divide. So I would take 6.02 times 10 to the 23rd times 1 times 40, and that comes out to be 2.4 times 10 to the 25th. Then I take 6.02 times 10 to the 23rd times 1, which is itself, and then I would divide these out to get my final answer of 40 grams of calcium. Okay, sorry about that. So I know most of you probably saw that this number and this number would go on and cancel out, so your answer would end up being 40, but that's not always how it's going to be. So I wanted to show you how you would set these up and solve. So your atoms of calcium cancels out, your moles of calcium cancels out, and you're left with grams, which you're solving for. Let's take a look at number 6. In number 6, we are trying to find our number of atoms. And this time we're working with aluminum. And we are given 540 grams of aluminum. So this time we're going to be working in the opposite direction. So we're going to start here in mass and go to moles. That's your first step. Then moles to your number of atoms or number of particles, and that's your second step. So since you're starting in your mass box, that will go on the bottom of your equality, and the box you're going to, which is moles, will go on the top of your equality. So grams of aluminum will go in the bottom. Moles of aluminum will go in the top. Since both of these substances are the same, I have 1 mole. And I look up the mass of aluminum on the periodic table around to the nearest whole number, which is 27. That's my first step. My second step is going to be going to moles to your number of atoms or particles using Avogadro's number. So the box we start in is moles, so that goes in the bottom. And the box we're going to, which is our number of particles or atoms, and this is where Avogadro's number goes, the 6.02 times 10 to the 23rd atoms of aluminum will go in the top. And since both of these substances are the same, it is to 1 mole. Now I multiply the 540 times 1 times the 6.02 times 10 to the 23rd, and I get 3.25 times 10 to the 26th. Then 27 times 1 is 27. Divide, and my answer is 1.2 times 10 to the 25th atoms of aluminum. So my grams of aluminum cancel, my moles of aluminum cancel, I'm left with atoms of aluminum. Number 6 is an example for 7 through 10.